So, okay, so let's continue here. Now, let's talk about how to do some unit conversion. For those of you who have done Chem 20 and physics, this should be piece of cake, all right? So, first thing is to recall on the previous slide, we talked about that 360 degrees is the same as 2 pi in radian. You can downscale it a little bit, divide this by 2, divide this by 2. So that means you can also say that 180 degrees is the same as pi in radian. Okay, so again, I'm going to share some tricks with you guys because you are my students. If I were you, I'll just simply remember this. This is not on your formula sheet, and this is very handy. Pi 180 degrees. So let's finish this one here. There are two ways you can do the conversion. Actually, one way, except you can use either this relationship or this relationship. So there are two ways for the conversion. One is going from degree to radian, and the other way is the other way around, from radian to degrees. Okay, so if you have degrees, you can simply times it by 2 pi over 360 degrees, because we know that there are 2 pi in every 360 degrees. But as I said, if I were you, I would use this. It's nice and easy. It's just more like the reduced form, the simplified form. You can replace this by, let me use a different color, pi over 180. So we did something like this on the previous slide. So anyway, in conclusion, whatever angles you have, times it by pi divided by radian. When we say pi, we just leave that. Okay, and then if you do it the way around, you just flip this because we're doing the opposite process. So if you're converting from radian into degree mole, sorry, not degree mole, but in degrees to into degrees, then you can do there are 360 degrees in 2 pi. And again, you can use the simplified version or the reduced version. This again, this is the one I would strongly suggest you guys to do. You can say the same thing. Take whatever degree you have in radian, times it by 180, and then divide it by pi. Then whatever answer you end up with, that would be your angle measurement in degrees. Alright, so let's put this into use. And I know some of you may be confused. Should I write down RAD, radian for degree or not? If you look at the first slide of the notes that we did today, we would, if we just talk about the relationship between the arc length and the radius. Here, whenever you see some numbers measured written like this, that means like the pi thing in an in representing an angle, we assume that this is already radian, because every time we see pi, either it means it has something to do with the circumference or radius, or it is an angle measurement. So draw each angle in center position and convert to the other unit. So this, when you see this, you have the radian, so you have the pi, so that means this must be an angle measured in radian. So we would not physically write out RAD radian here. So now, if this is the angle in radian, that means we have to convert that into the degree mole. All right, so before that, let's sketch this here. Well, let's do the calculation because we don't know how wide or how narrow this angle is. So now we all know that we would be multiplying it by the factor, the 180 thing, like pi is 180 degrees. If you want, you can do 2 pi is 360 degrees. Now the question is, should I multiply this by 180 over pi or pi over 180? Well, I'm going to teach you unit analysis that you learn in chemistry and physics. So let's say if you're saying, oh, I should multiply this by pi over 180 degrees. Okay, well, add the degrees there because you've seen a second y. Right, so no units cancel out. Obviously, something doesn't look right here. Right, So now if you do it the other way around, 180 degrees for every pi, or you can write down 360 degrees per 2 pi, then have a look, pi on top, pi on the bottom. So I'm not going to show you my calculator. You can do this simple math. So if you look at this, you have 5 times 180 divided by 3, and because I leave the angles there in degree, so therefore my angle, that's the radian mole, my angle here in the degree mole would be in degrees with a unit. Okay, so that gives you 300. I put a degree here, so that means this is going to be 300 degrees. All right, so let's sketch this. 90, 180, 270, 270, 360. So 300 would be somewhere here. All right, and hope you still remember the standard position from Math 20-1, starting here, 0 degrees, go counterclockwise, increasing, increasing, increasing. So that means that this is 5 pi over 3, or you can say this is 300 degrees. Okay, so let's quickly finish the rest. And if you look at this one here, this is already in degrees, so that means we want to multiply by a factor to convert that from degrees into radians. So again, it's just trial and error, so you don't have to memorize these two formulas here, right? They are literally the same thing, except one is flipped upside down compared to the other. So if you look at this, so let's say you don't remember the formula, let's reason it out instead. So let's do the one we did before, 180 degrees divided by pi, to convert that into radian. But look at this, the degrees, or there's nothing to cancel out, so we know this is wrong. So instead of saying 180 degrees over pi, now I know for sure it is going to be pi over 180 degrees. Have a look, the degrees cancel out. So basically, you just plug this into your calculator, and I would strongly suggest you to put that in fraction, that the way that I just showed you on my graphing calculator, like this. I'm not going to show this to you again, so have a look. Okay, so if you plug this into your calculator, 210 over 180, that gives you 7 over 6, and just leave the pi there. So our answer is 7 pi over 6. You don't have to write down RAD here like we did on the very first page, because anyone who knows math, including yourself now, when you look at the notation like this, involving a pi for an angle, that must be in radian. Okay, let's keep going. Right, so if you look at this, 118 degrees, so obviously you want to convert that into radian, so I will just do it right here. So pi over 180, then the degrees cancel out, quickly plug that in. So again, put that as fractions, 118 on top, 180 on the bottom, then you will end up with, in this case, 59 over 90. So you write that and read that as 59 pi over 90. Okay, let's finish this last one here. We are converting from the radian degree, from the radian angle into a degree angle. So you would times it by 180 over pi. So pi on top, pi on the bottom. So again, do this as fraction. So 11 times 180 divided by, oh sorry, you don't have to do that in fraction because we are dealing with a degree mode, so it could be like a decimal. So 11 times 180 divided by 9, that gives you 220 degrees. Okay, so let's wrap up this part with some word problems. So have a look, pause for a few seconds, and then hopefully you can figure this out without me. Let's continue. It says a Ferris wheel has a diameter of 18 meters. This is called radius. Radius. This whole length is called diameter. So if the diameter is 18 meters, so that means this length here, which is the same as this length, is, of course, 9 meters, which is half of that, which is also the radius. You might want to make a note. Okay, there's an emergency and you need to save someone at point P. You are at point A, so you're here, someone is here. And the angle is 135 degrees, so this is 135 degrees. What is the circular distance from A to B? So from here to here. I hope you still remember this is called the arc length. Okay, I don't know why I wrote that R. So arc length. Alright, so if you look at the formula sheet, there's only one formula you have learned so far, which is this. Theta is arc length divided by the radius. So in this case, let's manipulate this first. So that means to find the arc length, we take angle theta in radian times it by r. Okay, now we know the angle is 135, but it is not in radian. So that means we convert this into radian, times it by r, which is 9 meters, then easy. Okay, so we just applied the concept we just finished on the previous slide. So we have 135 degrees. And we times it by pi over 180 degrees. As you can see, the degrees will cancel out. So degrees cancel out. And then that's nothing new. The new thing is we combine everything together. So R, we figured that out, is 9 meters. This is not science, so I don't care if you put down meters here or not. As long as you put down a unit at the end, I'm alright with that. So 135. Now guys, I know so far when we talk about the angle in radian, we always just leave the pi. So look at these examples. 7 pi over 6, 59 pi over 90. But for a word problem like this, if you look at this, think about this. If you take 135 divided by 180 times 9, that gives you 6.75 pi. Now have a look at the answer. If I tell you that the arc length or the length here is 6.75 pi, you'll be thinking, or at least I would be thinking, what the heck are you talking about? Doesn't make sense. So when we do word problems or trying to find the length, we would multiply the pi in, or in the future you will see that even when we talk about angles, when we talk about, if you see some hints saying something like, oh, round your angle in radian to the nearest tenth or hundredth or something like that, then you know you should multiply the pi in. So now if you look at this, you take 6.75 times it by pi. I'll quickly do it here. 6.75 times it by pi. Enter. So that gives you 21.20 blah blah blah. All right, so the question did not mention about the rounding, so I'll just round it to your nearest tenth. So my answer would be 21.21 meters. As I said, this is not science, so you don't have to put down the unit here, but at the end, don't just say 21.21. What is 21.21? If you look at this, this is the last question we have for this section here. This one is definitely a good one. If you are exemplary type student, or if you say you good at physics, then you should be able to do that. Again, have a look, pause for a few seconds, and try to see if you can do this all by yourself. The hints are already here. Have a look, and hopefully that makes sense to you. Okay, so here's the question. A bicycle is traveling at 30 km per hour. Its wheels have a diameter of 74 centimeters. Find the angular speed. You may not have any background in physics, but who cares? Of course, I don't care. Find the angular speed of the wheel in radians per minute. Why did I highlight this? Because if you look at the question, it's more like a physics problem or kind of like chemistry problem. You want your answer in radians and minutes. Look at this. Kilometers and then centimeters. They are in different units. Hours, your answer should be in minutes. They are different units, so be careful. And if you are the visual type person, then here radians per minute, you can write that as radians per minute like this. So this is the unit for our final answer. If you even want to sketch this, you are definitely welcome to do that. So how do we do this? Well, step 1, find speed in centimeters per minute. This is more like physics problem, as I said. So I'll walk you through step by step. So first step, okay, convert this into centimeters per minute. All right, this is, as some of you may know, a linear speed. It's going from left to right, right to left, things like that. But here we're talking about angular speed. So this is angular speed moving around like this. All right. I don't know what your previous math or physics teacher taught you guys, but I'm going to do this kind of like Chang's way, the way that I think is the easiest to understand. Anyway, so how can we convert this 30k an hour into whatever centimeters per minute? So let's do this here. 30k an hour. If you want, put down a 1, right? If you don't feel comfortable. So now let's do it step by step. So let's convert kilometers into meters. So how do we do that? We times it by 1000. Okay, so if you do that, 30 times 1000, that gives you 30,000 centimeters. And then if you look at the bottom, convert that into minutes. Each hour has 60 minutes, so times it by 60. So 1 times 60 gives you 60. So that means you have 60 minutes. I'll briefly, if you look at the answer key, I showed you another way, so depending on which way you feel comfortable with. Now, let's keep going. So for the top, it's already in centimeters, so it is okay. And then the bottom is in minute. I don't know what I'm doing here, obviously. So if you look at this, times it by 1000 to convert that into meters. So that's in meters. Now we still have to convert the meters into centimeters. So what do? We times it by 100, because each meter has 100 centimeters. So if you look at that, 30,000 times 100, that gives you 3 million centimeters. Okay, and the bottom is already in minutes, so 60 minutes. So if you take 3 million divided by 60, do that on your calculator. I'm not going to show you. You should end up with 50,000 centimeters per minute. What does that mean? With a speed of 30k an hour, it's the same as the speed of 50,000 centimeters per minute. So you can travel 30k in 1 hour, you can travel 50,000 centimeters in 1 minute. Again, why did we do this conversion? Because look at that. These things, they don't match. Kilometers, centimeters. Because we need to find a common ground, same unit, so that we can do more conversion, more calculation. Now, if you look at this, we just figured out that with this speed, it is equivalent to 50,000 centimeters per minute. So this is the linear speed, moving in a straight line motion. But now, how can we translate this into circular motion, moving like this? So we need to take advantage of some prior knowledge. So we need to find out what the distance here in each revolution. So that's the next step. Find wheel revolution per minute. So with this speed here, how many rounds can you make in 1 minute? So the prior knowledge here is that the circumference, let me just write it down, which is the distance around, is 2 pi r. So that means each revolution, like this, doesn't matter clockwise, counterclockwise, back here, or starting here, 12 o'clock, go run 1 revolution, 1 round, stop right here. You can find that distance in with this formula, 2 pi r. And of course, the r here is half of this. So divide this by half. That means the radius is 37 centimeters. So now if you look at this, 50,000 centimeters per minute. Now pause a few seconds. How do we incorporate this part here into this calculation? Would you say there would be 2 pi r per revolution, or 1 revolution per 2 pi r? If you still don't get it, quickly have a look and think about this. Alright, so I hope you figured that out. If not, just follow me here. In this case, we will write that as 1 revolution per 2 pi r, because the units will cancel out. If you write down 2 pi r per revolution, the units don't cancel out. So let's jot this down. Revolution, 1 revolution per 2 pi. What's my radius? Right here, 37 centimeters. 37 centimeters. And as you can see, if you write this way, then the centimeters would cancel out. If you flip this upside down, the units don't cancel out, then you know something is wrong. So, alright, so multiply that in, that would give you 215.07 revolution per minute. So you can travel that distance in every minute. So if you translate that into a circular motion, that means you can travel 215.07 215.07 revolution. So you can do this 215.07 times every minute. But we are not done. We want to find out how the angle measurements in minute. So we know we can do this 215.07 times per minute. So now what is the total angles? So this will give you 360, 360, and 360. Again, doesn't matter clockwise or counterclockwise. So just keep adding 360, 360, 360. So now if we know we can do 215.07 times like this per minute, let's convert this into degrees. So 215.07 revolution per minute. And by the way, this is more like for those of you who drive a manual vehicle, manual transmission. I'm sure you have heard about RPM. And for those of you who drive an automatic, you may still see this tachometer thing on your dashboard. Anyway, so of course we times. Now, what do we multiply by? We are going to convert this revolution into an angle measurement. So this is 360, but then if you look at the question, we talk about radians. So we don't want 360. We don't want to say 360, 360. No, we want to say 2 pi, 2 pi, 2 pi. So that gives you 2 pi's per minute. I hope you can see that. Not 2 per minute, 2 pi per revolution. Or you can say 1 revolution per 2 pi, but if you look at this, we wrote it this way because by doing so, the revolution would cancel out. So we end up with whatever pi per minute. That's good. But not just that, because the question talks about radians, so we cannot just leave that as whatever pi per minute. Nope, we have to multiply the pi in. Remember the last question, when we talk about the length, we cannot leave that as, oh, the length is 6.75 pi meters. What the heck is that? Multiply that in. Okay, so same thing here. Oops, wrong color. So 215.07 times 2 times pi, or you can use 3.14 thing. Try to use the whole thing, don't just use 3.14. Okay, otherwise your final answer would be off, and then that would be out of minute per minute. So if you do that, again, the question did not mention about the rounding. Oh, actually we are on third step, sorry. Convert to radians per minute. So we for the rounding, we just leave that with 2 decimal places or round it to the nearest hundredth. So you should get 1331.35 radian per minute. So that means it tells you the amount of angle measurement for every minute.